We're working on a similar project, but a bit of twist of providing the MCPs and tool usage on your own infrastructure or specified execution node. So the Rhea is a framework that incorporates RAG search and MCP servers that was developed by the Rhea that dynamically searches for the best suitable tool for your purpose based on the natural language query. So it incorporates the tools from the Galaxy shed that follow the corresponding XML schema and utilizes the retrieval augmented generation for the best matching. It is compliant with MCP and works with Clone Desktop and other MCP clients. So there is also your code here if you want to see an example with Cloud. Galaxy Toolshed integrates more than 10,000 biomedical tool wrappers in unifying schemes. That's why it's so convenient to utilize it. So the Rhea's architecture is a bit different. It actually takes a description of each tool, wraps it into the mini container, into the separate execution environment, and it can launch it on the remote high-performance computing environments via the Academy workflow. So basically, the MCP server gets the description of the tool and the task along with the data that is accessible via Redis server. Sends it to the LLM client agent which would call tool. Then MCP server would launch parcel job on the remote HPC server and finally get the result. There is also a need for bioinformatics complex pipelines, for example, for the viral genome annotation, where we would need to combine the usage of multiple tools and even AI decision making in the process of a single pipe workflow execution. So for this purpose, we're developing a nanobrain workflows, a configuration-driven workflow structure that is very flexible and allows you to specify the usage of each agent or tool via a separate configuration file. Here is an example of the multi-agent RAG pipeline, the corresponding framework. It starts with the user query, performs RAG search after the query refinement by the agent, summarizes context, and finally goes through the critical evaluation by another agent. And what is important, it can iteratively refine itself. During this hackathon, we were adding the Galaxy MCP as an external information to identify the corresponding possible tasks and tools that can be used during this workflow if we want to adapt it automatically. Over here, we modified the first step of the workflow by adding the task extraction agent and the Galaxy MCP. Unfortunately, our integration is not as good, while the task extraction works perfectly. The Galaxy output is not well integrated, so we're getting the output close to this one. If analyzing each task that your user asks, separate it in distinct bioinformatics steps, and ideally, the Galaxy tool MCP would extract the output. Currently, we see that Galaxy MCP performs well, but our agent fails to integrate the output back to the response. That's it. Any questions?
Thanks, Oleg.